Hello, everybody. We are back with another visual pattern challenge, this time leaves on trees. So here's step one, step two, step three, or tree one, tree two, tree three. And your job is to look at this pattern and see if you can figure out how many leaves are going to be on tree number 4. And then tree 43 if this pattern were to continue like this. And along the way, can you write an equation that could be used to express the number of leaves on any tree at all? So that's the challenge today. If that sounds interesting to you, pause the video and see what you can do. All right, I think this is a pretty difficult one today. I'm seeing 1 leaf here and then suddenly 5. So that's growing by quite a bit. And then this one, well, that's 11. If we were adding 4 each turn, so 1 up to 5 would be adding 4, then this should be 9, but it's 11. So my first thought is that this is not a simple linear pattern. But what exactly is going on? I think I'm going to start with just analyzing the numbers to verify and see if we can get any clues about what kind of pattern this might be. So I'm going to put the step number here and the number of leaves here. So in step 1, we've just got 1. In step 2, we've got 5. In step 3, we've got 11. And I think at this point, I'm just going to try to visually predict step 4. So what actually happens from step to step? So I start with 1 row, then I have 2 rows, then I have 3 rows. So I guess I'm going to have 4 rows. One of them is shorter than the rest, right? So there's a short row on top, and then here we're going to have 4 rows, so 3 longer ones. And the top row goes 1, 2, 3. So I guess this one's going to be 4. And whatever's on the bottom is 1 more than that. So I'd have rows of 5, 5, and 5. So just following this visual pattern, I think I'm going to have 19 for tree number 4. So let's put that in our chart too. It'll help us have enough numbers to analyze. To analyze numbers in a pattern like this, what we usually do is take the difference between the steps. So 5 minus 1 is 4, 11 minus 5 is 6, and 19 minus 11 is 8. So this is not all the same number. I mean, we noticed that when we looked at it at first. So it's not a linear pattern. If the differences were all the same, it would be a linear pattern. It's not. So we can go ahead and take the difference of the differences. So 6 minus 4 is 2. 8 minus 6 is also 2. Aha. When you get the same number in the difference of the differences, you know that this is going to be a quadratic, and we're going to have an x squared in here somewhere. Now, how can I see x squareds in here? If I look at this first one, this is x squared. 1 squared is 1. So that makes sense. So maybe this equation is just x squared. But if I look at 2, I've got my 2 by 2 square plus 1 left over. So that doesn't work. And if I look at my step 3, I've got a 3 by 3 square with 2 left over. And so I can think of this as having 0 left over and then 1 and then 2. And that pattern is good because it's going up at the same rate as the step numbers. It just doesn't equal the step numbers, but we could fix that. So we're going to have our x squared plus something. And that something is actually going to be 1 less than the step number. So I'm going to take the step number and subtract 1 from it. So I think that might be the equation, but let's test it. Okay, so if y equals x squared plus x minus 1, we would have 1 squared plus 1 minus 1, right? 1 is the step number, so we put that in for x in both places. Well, 1 squared plus 1 minus 1, well, this is 0, so that does equal just 1. So that does work out for step 1. Let's try step 2. So y equals 2 squared plus 2 minus 1. So that would be 4 plus 1, that would be 5. Let's try it for step 3. Y equals 3 squared plus 3 minus 1. And that would be 9 plus 2, that would be 11. Aha, I think we have it. So that was pretty tricky. I think seeing the square pattern in here and then figuring out how much to add and having to subtract something from the step number as the right amount to add was pretty difficult. So if you got that, give yourself a pat on the back for sure. I'm going to write this down here, and I guess I don't really need those parentheses. It was kind of helpful to me in thinking about it, but there's no mathematical reason to keep them. So I'll just write it like this: x squared plus x minus 1. Now, once we've got our equation, we can use that to calculate the number in step 43. We just have to plug in 43 for x as the step number. So y equals 43 squared plus 43 minus 1. So 43 times 43 is 1,849. And then we're going to add 43 and subtract 1. So that's like adding 42. So that's 11, and that's 9. So 1,891 leaves in step number 43. Did you come up with that? How did this one go for you? Did it stump you? Did you crack it easily? Let me know. Thanks, everybody.